Hello everyone, we are Team 15 and our project name is English Short Story Summarization using Actor Critic Model, and our team include Haoxin Ma and Chuanfei Zhang. So let's first introduce our problem. Text summarization is the problem of creating a short, accurate, and fluent summary of a longer text document. Text summarization is generating a shorter text of one or several documents while preserving most of the main idea of the input. And automatic text summarization methods are greatly needed to address the ever-growing amount of text data available online to both better help discover relevant information and to consume relevant information faster. And our motivation to doing this project mainly contains 2 points. The first is that there isn't any existing dataset or research focus on the summarization of English short story, which may be useful for education or researchers on English literature. And another point is the existing automatic metric for summarization takes such as Rogue and Meteor have serious limitations. So one point is they only assess content selection and do not account for other quality aspects such as fluency, grammatical coherence, etc. And another point is to assess content selections. They rely mostly on lexical overlap, although an abstractive summary could express the same content, but reference without any lexical overlap. And the third point is, given the subjectiveness of summarization and the corresponding no agreement between annotators, the metric were designed to be used with multiple reference summary per input. But however, recent datasets such as CNN, Daily Mail, and GigWord provide only a single reference. So our goal for this project is mainly 2 points. One is develop a novel neural network with actor-critic structure for text summarization, and evaluate and compare with BART and SAMSIM. Another point is collect our own dataset for English short story summarization and transfer the above network and our own network to this new dataset and evaluate the performance. So about the project, the related work include first, CS7650 is create a dataset of scientific paper from the open access paper in the computational linguistic domain, and we will make comparison between CS7650 dataset and English short story dataset. And the second is Rogue. The metric is widely used as the metrics of text summarization, as one of our main target is trying to use critic model to improve the evaluation effect. We will compare the result between critic model and Rogue. And the third, for the text summarization model, Rush proposed a fully data-driven approach for the abstractive sentence summarization, and they use a local attention-based model to generate each word of the summary conditioned on the input sentence. And also recently, large-scale pre-trained language models such as BERT and BART are also proposed, and demonstrate the great ability of completing the task next text summarization. And for this project, the dataset and the many primary dataset we use to train our network is the CNN DM dataset. And for the CL77 dataset and the short story dataset for comparison, the text and the some English short story dataset is collected from the internet. And then the sample dataset could see the left figure, and we could compare, say, the statistic of the two datasets for CL77 and English short story, and respectively. The number of documents is around 900 and 400, and the average document tokens is 28,000 or 27,000. The summary tokens is 1,217, and then the summary sentence is around 7.9 versus 3.0.
Our proposed taxonomization network is based on the actor-critic structure, which is widely used in reinforcement learning. Our structure consists of two different networks, namely the actor network and the critic network, which are trained alternatively to compete with each other. The objective of the critic network is to classify between the generated summary from the actor network and the reference summary, while the actor network is trained to generate high-quality summaries that can fool the critic network. In this way, the actor network, which is responsible for generating summaries given the input document, will be able to learn from the difference of its generated summary and the reference summary. While training the critic network, we will fix the weight of the actor network. We will take the generated summary from the actor network and the reference summary, concatenate each other with the input document, randomly choose between these two, and will feed it to the critic network. The critic network will then be trained with the cross-entropy loss. While training the actor network, we will fix the weight of the critic network. The input network will take in the document and the reference summary and generate its own summaries. The generated summary will be concatenated with the input document and fed to the critic network. The probability from the critic network will be used as part of the loss to train the actor network.
We use the ROGUE score to evaluate our model and the baseline model on the test set of CNDM dataset. When evaluating the baseline model, we use the pre-trained weights. However, since the original baseline model BAT and SAMSIM are trained with a different maximum input size, we adopted the pre-trained weights for both baseline model to maximum input size of 1024. After this adoption, there is a significant drop in the evaluation score for BAT, but not for SAMSIM. So we report two scores for BAT, and then the result is here. And in automatic evaluation, our model outperforms the baseline of BAT by several percent point in ROGUE scores. However, our model only achieves a similar performance as the baseline SAMSIM model. We think this is mainly because we haven't trained an actor to converge. As shown in this figure, both the total loss and the critic score are still showing clear sign of decreasing, which means the actor has not converged yet. The critical score is still high, larger than 0.7 when we stop training, which means the actor hasn't learned to fool the critic. Therefore, if we keep training for more training steps, it is possible for the model to achieve better performance. modifying a training strategy may also has better result. And currently, we try to first train the actor long enough to for the critic before switching to the next loop and start training the critic. It may be better to first train the actor for only a while until the actor gets a little better at fooling the critic, and then go ahead to train the critic. In this way, it is possible that the decreasing in noise remain fast throughout the training, so we can achieve better performance in equal or less time. And the hyperparameter we use is not fully tuned, and the current critic network structure we use may be too good at classifying between the generated summaries and the reference summaries, so the critic score won't decrease much no matter how hard the current actor network tries. So it may be better to switch to a different critic network. Currently, the effort commonly the errors commonly seen in the generated summaries from our network including overemphasis on names, such as shown here. The unimportant name, the draw carry and the lucky 7 is included, and also over sensitivity to numbers, such as shown in 3a, table 3a, and then the repeatance of common token shown in 3b. And we have run the experiments on both CS7650 dataset and our English short story dataset, and all the three models have been trained for 50 epoch on both datasets. And we run automatic evaluation with row score on the test set, and the evaluation result is shown here. Currently, we are truncating the input to 1024 tokens, which will lose a large part of information because input in both datasets are much longer than this. We think this is the main reason why all three models have similar performance on the two datasets. And finally, in this project, we proposed an actor-critic structure for text summarization. In our structure, there are two networks trained to compete with each other. The critic one tries to classify between the generated and the reference summaries, and then the actor one tries to generate summaries that can fool the critic. From the result of our project, we find learning text summarization from the difference between the reference and the generated summaries by training two model adversaries can improve the quality of the generated summaries. Summaries generated by our structure tend to extract salient information while taking a different form and meaning from the reference one. And we also find that beside learning from the semantic similarity between the reference and generated summaries, it is also effective to learn from the difference between the two. While learning from semantic similarity encourages the generated summary to have similar meaning as the reference one, learning from the difference appears to learning something more representative, as the summary generated from our model have extracted the important information while not having similar meanings as the reference method. So that's all. Thank you for listening to this presentation.